Hello, this is Nicole Eidenberg with Fidelity Investments. I'm currently a squad leader in our technology organization supporting a finance application. Recently, I had the opportunity to take a class at Duke University on machine learning foundations for product managers. In the next upcoming slides, I'd like to demonstrate some of the learnings that I had. Today's agenda, I'd like to go over the actual problem. I'd like to demonstrate some of the features and determination. I would like to demonstrate the test set and training, my validation approaches, and finally the performance of the final model. Today's project topic is to build a model to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. There is a set of almost 10,000 hourly average ambient environmental readings from sensors at the power plant. The first piece will be the problem, which is our starting point. Our starting point has 4 features and 1 target. The features include 4 sections: AT, which is the ambient temperature, B, which is the exhaust vacuum, AP, which is the ambient pressure, and RH, which is the relative humidity. Our target is the PE, which is the net hourly electrical energy. And the problems to solve right now is to determine what type of machine learning is needed to predict the PE and select the appropriate out metric to evaluate performance. Next, we're going to discuss the machine learning approach and appropriate output metric. So from a machine learning approach, using the data set that we have been given, there's definitely a linear relationship between the features and target. Supervised learning algorithms based on linear regression will be used. Some of the output metrics that are going to be utilized is the R-square, which will be used for the output, but I also will attempt to use MSE, which is the Manley squared error, and MAE, the mean absolute error. So we'll start with features to be consumed and identify algorithms. So one of the first things I really looked at was the multiple linear regression, because there are 4 features, but a simple linear regression should also be tested for just a comparison. So below are the results for the single linear regression. So as you can see, AT and B are of high importance. I'd like to note that typically when it's over 0.7, that yield usually results in getting good quality from your model. As you can see, AP and RH are on the low to mid of importance. But overall, it does infer that with using AT and V, we're definitely going to have high yield results. Next is the test set and training. So using the data from that single linear model, other combinations should be tested using a multiple regression evaluation. And typically a training set, you want to come with an 80% validation, 10%, and a 10 set, 10%. So I've grouped the features by just groupings. So we'll look at the AT and B, we'll look at AT and B and add AP, and then also add RH to that last set. When looking at the multiple regression with training sets, which I did in Excel, we were able to identify the intercepts for each of the coefficients. And then as you can see, the results for each of the groups are laid out within this table. Okay, so now we're taking a look at the validation approaches. So using a validation set, we can show the correlation of the models, and all 3 models could be used. So if we take the first row, which is the AT and B, and using the model, you get a R-square of 0.92 an MSE of around 25, and the MAE of 4. The next model yields similar results, again 0.92, 24, and approximately 5. And then on the last one, yielded a little bit different on the MSE, but their R-square and MA were in line with the other two. Okay, lastly is the performance model. So using model 3, the calculation of the error metric is done using a test set, and these results demonstrate that they are in line with the validation set. That concludes the overview of the problem set that I was tasked to do. Thank you very much for listening.